Hello, welcome to ANS Solver. This is the fourth question of the paper. So the heights of a certain variety of plant are normally distributed with the mean 110 and the variance 1050 centimeters square. Now they have taken two plants, okay, two variety of plants, okay, in random, okay. Find the probability that the height of one plant, okay, is at least 1.5 the height of the other. Now see, I have taken a plant 1 and plant 2. So now let me assume that the probability of plant 1, okay, is at least basically means gives the indication of the more than equal to sign, correct, is at least one of these plants is at least 1.5 times the other. So let me assume a case like this. Okay, so now I can write this as p, the probability of p minus 1.5 p2, which is more than equal to 0. Okay, so now what I need to do is I basically need to calculate the mean, which is the plant 1, plant 1 minus 1.5 times the plant 2, which is now equal to, basically see, plant 1, I know my mean is 110 minus 1.5 into the mean of the second plant is also 110. So I can simply solve this as 110 minus 1.5 into 110. So the value I get here is negative 55. Now, I have my variance here basically as plant 1 minus 1.5 into plant 2. Now this will basically be the variance of plant 1, which I know, one second, I'll write it. The variance of plant 1 is 1050. The variance of plant 2 also I know is 1050. Now, two important things you need to know. Okay, first, the variance can never be negative. That means the sign you will have here is positive. Okay, because variance can never be negative. Okay, and now here they are stating that this is 1.5 times. Times suggests it's multiple. Okay, multiple. So that suggests that this is 1.5 square. Okay, this is what we do when we have multiples, correct? Basic concept. So yeah, now what I can do is I can simply solve this on my calci. So I have 1.5 square into 1050 plus 1050. Okay, which will give me, yeah, just give me 1 second, I'm calculating it. The answer I get is 3412.5. Now what I need to do is I'll make my normal distribution curve something like this. I know the mean I have here is minus 55. Correct? The value I have is 0 because I need the values more than 0. So I know 0 lies somewhere, in the opposite direction. Okay, so yeah, something 0 will lie somewhere here, and I need the area which is more than 0. Okay, so now I know my z is equal to the value minus the mean over the standard deviation. So this will basically be 0 minus 55 over the standard deviation, which is the square root of the variance. So this is the square root of 3412.5. So now I can write this as z equals to 55 over the root of 3412.5. Okay, so the value I get here is 0.9415. Now what I need is I need more than this z value. So I know phi basically means less than 0.9415, but because I need more than, I do 1 minus the phi of 0.9415. Now to solve this, you can go on your calci. So on the calci, what you can do is click on mode. When you click on mode, click on 3 where stat is written. Now when you click on 3, click on AC. Now when you click on AC, what you can do is click on shift, okay, then click on 1. Now click on 5 where distribution is written. Now when you click on 5 on the calculator display, you'll get 1p, 2q, 3r and 4t. We importantly need to know the option 1 and 3. 1 basically means where p is written, it basically means less than. Okay, this means less than. And r basically means more than. So basically p means phi and r means 1 minus phi. So I need to calculate 1 minus phi here. So I click on option 3. Okay, so when I do that, when I click on option 3, I get something like r with a bracket here. So in the bracket, what I need to do is I simply need to put 0.9415. So the answer I get here is 0.17322. Now comes the important part. Is this your final answer? No, you are wrong. See, when I started the sum, I told you I'm assuming that plant 1 is more than equal to 1.5 of plant 2. But here they are saying any one of the plant, okay, any one, okay. It's not necessarily plant 1 is more than plant 2 or plant 2 is more than plant 1. So because any one of them can become more than each other, 1.5 times more than each other, I need to multiply this probability by 2. Because any of them can become. So when I multiply this by 2, I get 0.346, which is basically the final answer of my question. So this step is really important to understand. Many students will get carried away, but don't. This is a very good question. Yeah.